Welcome to another exciting educational video brought to you by Up Vision Concepts Academy. So today we're looking at past WAEC math questions on algebraic processes. So sit tight and enjoy this video. If you're yet to subscribe to our channel, kindly subscribe to our channel to get more of our videos. So we dive in. The first question here is to simplify this algebraic expression. So I have 3x plus 5x plus, minus 2, minus 2. Now within 2x, so the thing with algebra is that you have numbers mixed with letters. And what you should do is to inspect to see that all the terms have the similar alphabet attached to the numbers. For example, this is a three-term algebraic expression where this is the first term, this is the second term, and this is the third term. Okay, so the plus sign goes with the term. So again, 3x plus 5x minus 2x is a three-term algebraic expression with every term like, similar. Why? Because they have x in common. They have x in common. So what we're going to do, we're going to treat them like a like term and add them, do the operation on them together. So I have 3x plus 5x. That will give me 8x. 8x, right? Then minus 2x. 8x minus 2x will give me 6x. So the answer to this simple algebraic expression is 6x. So we'll go to the next question. So it says expand this algebraic expression. So I have x plus 3, open and close bracket, x plus 5. What this means is that I will multiply each term on the first bracket by the second term, the second bracket. So first of all, I will go like this. X here will multiply x here. Then I'll have the expression. This same x will multiply 5. So I'm having two terms. Then again, 3 will multiply x and 3 will multiply 5. So I'm having 4 terms after this operation, after this procedure. So the first thing, x times x is x squared. X times 5 is plus 5x. Note the signs in front of the terms, right? Then plus 3 times x is 3x and 3 times 5 is plus 15. Okay, so I have 4 terms here. I have an x squared, I have a 5x, a 3x, and a 15. Note that these two middle terms, 5x and 3x, are like. Why? Because they have x in common. So I'm going to do the operation on them. I would like, starting from the first term again, x squared plus 5x plus 3x will give us 8x. Okay, 8x and 8x, then the last term there is 15. So this is the expansion of this particular question. All right, so the answer is 8x, x squared plus 8x plus 15. So the next question is factorization. Factorization has to do with making factors in the algebraic expression. So the expression I have here is x squared minus 9. This can also be written as x squared minus 9 is actually 3 square. So if I put 3 square here, it's the same thing as 9, right? So I have an interesting situation here. We call it difference of 2 square. So I'm going to write again to say that if I have a square minus b square, it is known as difference of 2 square, where this translates to now become a minus b and a plus b. So this is an identity called difference of 2 square. So I'm going to apply this identity here for this situation. I will have it as x minus 3 and x plus 3 multiplying themselves. So this is the factorization of this particular expression. So we'll come onto linear equation. So a linear equation is an expression where you have the highest power of the variable to be 1. So this is the question we're given. The variable here is x. So I have 3x minus 5 is equals to 10. So the highest power of the variable x is 1. Don't have any other variable here. So the highest power of the variable is 1. If you have the highest power of the variable as 2, that becomes a quadratic equation. So that's the difference between linear equation and quadratic equation. So for linear equation, once again, the highest power of the variable is 1. Our goal is to find the value of x that makes this equation true. This equation. What is the value of x that makes it true? That is, what is the value of x that will make this side of this equation equal to this side of this equation? So you have this equality sign. That this equality sign makes an equation. You have the left hand side. This is the right hand side. Sorry, RHS, and the left hand side of this. So our task is to find the value of x that makes left hand side equal to right hand side. Okay, so we are going to solve this equation. The first thing we'll do is to write out the expression again. 3x minus 5 is equals to 10. So this is minus 5. When it crosses the sign of equality, it becomes plus. So we are collecting like terms. Our goal is to take this number to this side of the equation, to the right hand side, to meet with its like term, which is 10. So I have 10 and minus 5, which are numbers without a variable attached to them. And I'm taking minus 5 on the left hand side to join 10 on the right hand side. So when minus 5 crosses the equality sign, it becomes plus 5. So I have 3x is equals to 10 plus 5. Okay, I can also rightly put it as add both sides, add 5 to both sides, so that 5 will cancel on this side, right? So I have this expression now. So I have 3x is equals to 10 plus 5 is 15. At this point, I want x to stand alone. So I'm going to divide both sides by 3 so that I remove detach 3 from x. So I have 3x over 3 is equals to 15 over 3. So 3 here 1, 3 here 1, 3 here 1, and 3 into 5, 15 is 5. So x is equals to 5. So x is equals to 5, we make this equation true. Let us check. Let's check. Again, if I have 3x minus 5 is equals to 15, if I put where I see 3, where I see x, I put 5. That's the answer I'm getting. Minus 5 is equals to 10. So this side of the equation is what? 3 times 5 is 15. 15 minus 5 is 10 here, and I have 10 here. So it means that this answer we have gotten is true. Okay, so the next one is linear equation again in what form? Say if 2x plus 7 is equals to 15, find x. 2x plus 7 is equals to 15, find x. So the next thing we do is to take 7 to this side. When 7 crosses to this side, that's the plus sign, plus 7 goes to that side, it becomes minus. So it is 2x is equals to 15 minus 7. Okay, so I have 2x is equals to 15 minus 7 will give us 8, and the 2x divided by 2 is equals to 8 divided by 2. What are we doing? We're trying to divide both sides by 2 so that we can isolate x on this side. All right, so 2 cancels 2, x remains alone. 2 here 1, 2 here 4. So x is equals to 4. So x is equals to 4 is the value of the variable that will make this equation true. If we check here, we put 2 into 4 plus 7 is equals to 15. That is, we have put in 4 where we see x. 2 times 4 is 8. This is 15 here. 2 times 4 is 8. 8 plus 7 is equals to 15. That is 15 on this side and 15 on this side. So that means x equals to 4 is true. All right. So the next one we have is quadratic equation. Like I said earlier, quadratic equation is an equation where the highest power of the variable is 2. Okay, so that is, there's a way to solve this. It means that we're going to be getting two answers, two solutions to the variable. We call them roots of the equation. Roots of the equation. So I'll write this equation out again. X squared minus 5x plus 6 is equals to 0. So I have the first term, the second term, and the third term. So what I will do the first time is to multiply the first term and the last term. So the first term is x squared, the last term is 6x. Sorry, 6. Multiply the two of them, I will get 6x squared. So I will look for two numbers such that when they multiply themselves, they will give me 6x squared. And when they add themselves, they will give me the middle term, right? So those two numbers are minus 3x and minus 2x. So let's check. Minus 3x times minus 2x will give me 6x squared. And if I add the two of them, minus 3x plus minus 2x will give me minus 5x. So I have gotten the two numbers that satisfy that condition. That is, two numbers such that when they multiply themselves, they will give me this 6x squared. And when they add themselves, they will give me the middle term in the quadratic equation. So I'm going to replace the middle term by the two numbers I have found. So I come here again, write the equation again, x squared. So instead of writing minus 5, I'll put minus 3x and minus 2x. See, replace these two, I'll replace minus 5x with these two terms. If you look at it, I'm not losing anything because minus 3x minus 2x will give me minus 5x, right? So I continue and I write plus 6 is equals to 0. Okay, so let me take some things off so that I can have ample space. Okay, so this is plus 6 is equals to 0. So at this point, I have 4 terms in this expression. I've changed my 3 terms into 4 terms. So I'm going to start by grouping. I'll group the first 2 terms and I will group them like this: x squared minus 3x. Then I group it minus, then I group the last two terms, 2x plus 6. Okay, all equals to 0. Now I'm going to check what is common in the two groupings, that is each of the groupings. For the first group, x is common in the first group, right? So if I bring out the common term outside, I will now add the remaining things inside. I have x and minus 3 inside, right? Then for the second bracket, what is common in that group is 2. I bring out 2 outside. The remaining terms here is x and plus 3. You see, I have x and 2 outside, so I'll write it outside, x minus 2. I'll write this and this, right? X and 2. But I will take one of these. You see that this other one here, x plus 3, when this outside minus act on it, it becomes minus. So x minus 3 and x minus 3 are the same. So I will take one of it as x minus 3, all equals to 0. I told to solve, so I'm going to get a solution for x, right? So I have two factors. Either x minus 2 is equals to 0, at this one is equals to 0, or x minus 3 is equals to 0. This one equals to 0. So two of them. So for the first one, for the first case, x is equals to 2. For the second case, x is equals to 3. So these are the solutions to this equation. Okay, so the next one I have is inequalities. So inequalities are some form of algebraic expression where you have the inequality signs replacing the equal signs. Instead of having equal to, you'll be having greater than or less than. But we solve them as if we're solving equation. but there are some exceptions to the rules. The equality sign will change the direction depending on the sign that you are getting. So let's see how this one goes. So I have 2x plus 3 greater than 7. All right, so I'm going to take plus 3 to this side of the equality sign of the inequality sign. I will say 2x greater than 7 minus 3. Once this plus 3 crosses, it becomes minus 3, right? So I have 2x greater than 7 minus 3 is 4. So if I divide both sides by 2, I have 2x over 2 greater than 4 over 2. 2 will cancel 2. 2 here, 1, 2 here, 2, right? 2. So I have x is greater than 2. That's the answer. So this is a variation question. It says when y is directly proportional to x and y is equals to 10 when x is equals to 2, find x is equals to 5. So this is written as y directly proportional to x. Now when we put the constant sign, that is introduce constant proportionality, you have y is equals to kx. So this translates to this. Okay, so we have two instances of substitutions. The first one is y is 10 when x is 2. So I want to find the value of k when y is 10 and x is 2. So get the value of k. So k is always constant. Once you can know what k is, you can bring it back and use it to find another variable, another instance, right? So for the first instance, y again is 10 and x is 2. Let's put this in equation 1. So I write 10 here as 10 is equals to k times x is 2. So k will be 10 over 2, which is 5. So k is 5. So I have another instance again. Find y when x is 5. So again, y is equals to k times x. So we're looking for y at this second instance, and we know that k is gotten as 5, then x is given as 5. So y at this instance is 25. That is the answer. Okay, so functions. You say if f of x is equals to 2x plus 3, find f of 4. What this means is that I'm going to be putting 4 where I see x in the expression. So I just come here, 2 open bracket, 4 close bracket plus 3. So 2 times 4 is 8 plus 3, and 3 plus 8 or 8 plus 3 is 11. So f of x is 11 when that is f of 4 is 11 for that expression. Yeah. Right. Okay, so we have a question on relations. State whether this relation is a function. Okay, so each input has only one output, right? So for instance, now if I put 2 into x, I will have x squared, right? If I put 2 there, I will have 2 squared, which will give me 4, only one output. If I put 3 where I see x, I will have 9, only one output. So for you to get what a function is, each input will give us only one output. All right. So this satisfies the definition of a function. So final answer, this is a function. So we're asked to simplify 2x minus 3 open bracket 4 minus x. So this is also testing us on how to expand. Our interest is what is happening here where I'm shading like this. So I have 2x. Now minus 3 outside times 4 will give us minus 12. And minus 3 outside times minus x will give us plus 3x. So these are like terms. 3x and 2x are like terms. So 3x plus 2x will give me 5x. minus 12. So the final simplification for this particular question is 5x minus 12. Okay, so the next question is expansion. Expand 2x minus 3, open bracket, close bracket, all square. So it's the same thing as 2x minus 3 and 2x plus minus 3, sorry. You do it twice, right? You do it twice. So we're going to be expanding. So I'm going to take this first term here and multiply by the first term here. At the same instance, I will multiply the first term and the second term. Okay, so let me do that. 2 times 2x is 4x. And 2 times minus 3 is minus 6x. Then minus 3 times 2x is minus 6x. Minus 3 times minus 3 is plus 9. Okay, so this first one is x squared, 4x squared, please. The first term, 2x times 2x is 4x squared. Okay, so 4x squared minus, okay, so minus 6x is minus 12x plus 9. So this is the expansion. So what to factorize? Again, this is a quadratic expression. Why? Because the highest power of the variable x is 2. All right, so to factorize this, again, I will write out the 3 terms: 2x squared plus 7x plus 3. So multiply the first term and the last term. I'm going to be getting 6x squared. So I look for two numbers such that when they multiply themselves, they will give me 6x squared. When they add themselves, they will give me the middle term. Those two numbers are 6x and x. So let's check. 6x times x will give us 6x squared. 6x plus x will give us 7x. So I'm going to take this and replace this with the middle term, right? I'll replace the middle term with this, right? So I'll write again. 2, excuse me. All right, so you have 2x squared. Instead of having plus 7x, I will have plus 6x x plus x plus 3. Okay, so I'm going to work on this and then factorize by grouping. So the first two terms and the last two terms, I'll group them together. What is common in the first two terms? This and this. What's common in these two? I have 2x is common. So open bracket. What's left there is x plus then 3. All right, you put your plus. So how do you know that what you have done here is correct? If you multiply again, that is 2x plus times x, I will get 2x squared. I multiply 2x times 3, I will get 6x, right? Okay, so let me take this off. Just want to illustrate. Yes. Okay, so I factorize. So for the last two terms, this and this, what's common there is 1. Have x plus 3. So you have to look for what is common in the two terms, right? So if you inspect, you see that this factor and this factor are the same. So I take them as 1, x plus 3, and this one outside and this one outside, we'll take them as another factor, 2x plus 1. So this is the final factorization. Okay, I can write like this: 2x plus 1 and x plus 3. That's the final answer. Okay, so I have linear equation, factorial of fractional. Fractional, yes. So this is a question here. X over 3 plus 3 is equals to 7. So I'm to find the value of x. Okay, so the first thing I'll do anytime I see fraction is to inspect the denominator. If there are more than one to one fraction, you can get the LCM of all the fractions and multiply each term of the expression by that LCM. So for this case, I only have one fraction, and the number I'm looking at there is 3 as the denominator. I'm going to multiply each term by 3. So I'll just multiply each term by 3. That translates to be 3 times the first term plus 3 times the second term is equals to 3 times the third term. So you see that what is constant in every of this thing is 3, 3, 3, 3, 3, right? So what's the essence? I want to remove the fractions, the denominator that is in this thing. So this denominator here in the first term, we go with this 3, and then I will have x plus 3 times 3 here is 9, equals to 3 times 7 is 21. Okay, so at this point, I will say x is equals to 9 will cross over to the other side, plus 9, and that come minus 9. So 21 minus 9. So will be x will be 12. 12. That's the answer. Okay, so this is quadratic equation. So we have this equation as x squared minus x minus 6 is equals to 0. So I want to find the values of x. There are two values here according to the power that I have here. So the first thing I do is to multiply the first term and the last term again. So I have minus 6x squared. So I'll look for the two numbers such that when they multiply themselves, they will give me minus 6x squared. And when they add themselves, they will give me minus x, middle term, right? So the numbers I'm going to be using is minus 3x and plus 2x. Let's check. Minus 3x times minus 3x times 2x will give me minus 6x squared, right? And minus 3x plus 2x will give me minus x. So I'm going to be putting this for this term. So I'm right again here, x squared. Instead of having minus x, I will have minus 3x plus 2x. Finally, minus 6 is equals to 0. So I'm going to continue to inspect the first two terms and last two terms. So what's common in the first two terms? What's common there is x. So what's remaining in the bracket, inside the bracket, is x again minus 3. So what's common in these two terms? I have 2 common there. What's left is x minus 3. Again, this is common to this, similar. So I will take one of it, and I will take the outside terms x plus 2. So this is the factorization, but we are to solve for x. So I will come here, either x minus 3 is equals to 0 or x plus 2 is equals to 0. So when I solve the first equation, I get x is equals to 3, and for the second equation, x is equals to 2. So these are the solutions to that equation. So we still have another one, quadratic formula. So I'm going to introduce you to the concept of quadratic formula. This is the formula. It says s is equals to minus b plus or minus square root of b squared minus 4ac over 2a, where a is the coefficient of s squared. So in this situation, a is 2, and b is the coefficient of x, which is 3. Then c is the constant term, which is minus 2. So this is a, b, and c. So I'm going to put everything in this expression. Okay. So I'm going to be having x is equals to minus b is 3, right? So b is 3, then plus or minus square roots 3 square minus 4 dot a is 2 dot c is minus 2, right? So all over 2 dot a dot 2, right? So x will be equals to minus 3 plus or minus, plus or minus. So I have, this is 9 minus, okay, plus now because I have minus and minus here. So plus, then 4 times 2, 8, 8 times 2 is 16. Okay, so I have 16 here, all over 2 times 2 is 4. See? Okay, so I have x is equals to minus 3 plus or minus. So 9 plus 16 is root 25 all over 4. Okay, so I'll continue here. So I have x. Okay, I will take this off. I have x is equals to minus 3 plus or minus. Square root of 25 is 5 all over 4. So x is equals to, I have minus 3, then the first portion at the middle is plus. So minus 3 plus 5 over 4, or minus 3 minus 5 over 4. Okay, so I'll explain what's going on here. So when we get to this point, when you have this point, let me mark the point out and do it again here. When you have x is equals to minus 3 plus or minus 5 over 4. Just know that you're going to have two solutions. The first solution is dependent on this operation up here. So I'm writing it as x is equals to minus 3 plus 5 over 4, or minus 3 minus 5 over 4. What we have done is to split this into two using these middle operations. So the first expression we go with plus, second expression we go with minus, right? So we'll solve that independently. X is equals to minus 3 plus 5 is 2 over 4, or minus 3 minus 5 is minus 8 over 4. So either x is either 1 over 2 or minus 2. That's the solution. So we have inequalities, compound inequalities. So I have two inequalities in this expression. So I'm going to solve it like this. 3 greater than 2 first. I'll get the answer. I'll solve 2x plus 1 greater than or equal to 9. Okay, so the first one, I'm splitting it. So the first one is this 3. The first one is this. I'm splitting it. So the answer is 1 we cross to meet 3 here. So when it crosses, it becomes minus 1. So 3 minus 1 is 2. So I have 2 here. Then 2 less than x, 2x, right? By the time I finish, divide both sides by 2, I'll get x greater than 2. Notice what happened. This is supposed to be 1 1 less than x. But if I flip it, it will be x greater than 1, right? Okay, so I have gotten this first part. So the second part will be 2x plus 1 less than or equal to 9. So I'm going to solve it. 1 we cross over to the other side, become minus 1. 9 minus 1 will give us 8, and 2x is on this side. So if I divide both sides by 2, I will get x less than or equal to 4. So I'm having two expressions here. So I'm going to combine them again in under 1. I will now have it as 1 less than x and x less than or equal to 4. Okay, so this is variation, inverse variation. So when I say y is inversely proportional to x, so the first thing we'll do is to find the relationship with the constant k. By the time I introduce my equality sign, y equals to k over x. And k will now become yx. So this is the relationship binding the constant with the variables. So if y is 4, and x is 3. This will stand, right? This will stand. This is the first instance. So let us find k when this is true. When this is true, let's find k. What's k? Let's find k. So k now be 4 times 3. So k will be 12. Now, if k is 12, is also 12 in the second instance. Second instance here says find y when x is 6. So I will come here, this equation, y is already the subject of formula. So I will say y is equals to k is given as 12 from here, all over x is given as 6. So y is equals to 2 because 12 divided by 6 is 2. Okay, so we have functions, composites. Functions, composite. It says if f of x is equals to x plus 2 and g of x is equals to 2x, find f g of 3. Okay, so what this means now is that there's a function and a function. This function inside g3, g of 3 is actually 2x. It's 2x. So we're going to be putting, for this expression, where x is 3, we'll put, where x, you see x, you put 3. Yes, for this expression, to get g of x. Okay, so if we say g3 is equals to g3 is equals to 2 into 3, right? So I get 6. So I've gotten g3. So f g3 is f6. So when you put it in this expression, x plus 2. When you see x, you put 6 plus 2, which is equals to 8. Okay, so we have inverse functions. Inverse functions. Okay, so if f of x, find the inverse of f of x is equals to 3x plus 1. So let y be x plus 1. So we'll now make a swap. That is, where we have x, we put y. Where we have y, we put x, right? Okay, so we'll make a swap. Direct swap. Look at it. Direct swap. So we'll solve for x, solve for y, I beg your pardon, making y subject of formula. So minus 1 will come to x and 3y will remain. Then y will now become x minus 1 over 3. So this is the inverse. That's the inverse. Inverse of that function is x minus y over 3. Okay, so we're going to expand and simplify. Expand and simplify. When you see this, don't be afraid. What it means is that I'm going to take this, multiply this first time to a. So the first number here giving me 3 terms, and this one too will multiply again 1, 2, and 3. Okay, so that's what happens here. So the first x here, multiplies this one, and the minus 2 here multiplies the same thing. So I expanded, so I'm having it as x times x squared, x cubed, x times 3x, 3x squared, x times 4, 4x. Then minus 2 times x squared is 2x squared, minus 2 times 3x is minus 6x, and minus 2 times 4 is minus 8. Notice how the minus outside here open up everything here and became minus, 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 right? So we collect like terms. Like terms means that every variable that are like will be grouped together and operated upon. Okay, so only x cube is standing alone, but I have x square in two places. So there's a 3x square and a 2x square. The two of them interacted to give me x square, because 3x square minus 2x square will give us x square. And I also have 4x, that's 4x and minus 6x. That will give us minus 2x and minus 8. So that's the final answer. X cubed plus x squared minus 2x minus 8. Okay, so we have to factorize this equation. So this is, again, is x squared plus 4x minus 12. Okay, so I'll multiply first and last term. So x squared minus 12 is minus 12x squared. Minus 12x squared. So I'm going to look for two numbers such that when I multiply themselves, they will give me minus 12x squared. And when they add themselves, they will give me the middle term. So what do I do here? I will take 6x plus 6x minus 2x. You have to get used to how to split this. So plus 6x minus 2x or times minus 2x will give me minus 12x squared. That condition is satisfied. And plus 6x minus 2x will give us plus 4x. So I'm going to use this substitute for middle term. So again, x squared, instead of writing plus 4x, I'll write plus 6x minus 2x minus 12. So I have 4 terms here, 4 terms here, 4 terms here. The first two terms, what's common in these two terms? X is common. So I have x plus 6 remaining. Then the last two terms, what's common? Minus 2 is common. So I have 2 outside, then x minus 6, right? So the factors are x minus 2, that is taking the outside terms, and x plus 6. So this is the factorization of this particular expression. So this is a linear equation. Two of them, we want to solve them simultaneously. So the first thing you do is to write them and name them 1 and 2. So I'll say I'll write x plus y equals to 7. I'll call this equation 1. And then x minus y is equals to 1. This is equation 2. So I'm going to inspect the two equations and look at the variables. I have variable x and variable y. My task is to find them at the same time. Okay, to find the values of x and y that satisfy these two equations together at the same time, right? That's what simultaneous equation means. Okay, so I'm going to look for an operation that I will operate on 1 and 2 to remove one of the variables. So if I look at y, I see a plus y, a minus y. So if I put a plus outside here, meaning that I'm going to be adding 1 and 2, so 1 and 2, then y will disappear. Let's do it. X plus x is 2x. Y plus minus y is 0. Why? Because y minus y is 0. Then 7 plus 1 is 8. So I have 2x is equals to 8. This is x, please. Is equals to 8. So if I divide both sides by 2, I will have x is equals to 8 over 2, then x is equals to 4. If x is 4, I can find y. I can substitute x is equals to 4 in equation 1. Okay, so equation 1 says x plus y is equals to 7. Where I see x there, I put 4. plus y is equals to 7. So I have y is equals to 7 minus 4. So y is equals to 3. So x now is equals to 4 and y is equals to 3. So this is the simultaneous answers for that equation. Okay, so another one again here is algebraic expression. Algebraic expression. Okay. Quadratic equation, right? Okay. So I have x squared plus 6x plus 5 is equals to 0. Okay, so what do? I will first of all factorize. X squared plus 6x is plus 5 is equals to 0. So I'll multiply this by this. I have 5x squared. So I'll look for two numbers that multiply themselves to give me this, and add themselves to give me that. So this is actually 3x and 2. Oh, no, this is not it. Sorry. It's 5x plus x. So if you multiply 5x by x, will give me 5x squared. If you add the two of them, to give me the center term, right? Center term here. All right, so I will replace it. I will say x squared plus 5x plus x plus 5 is equals to 0, right? So I'm going to factorize by grouping this and this term. What's common here is x, open brackets, x plus 5, right? Plus 1, what's common here? X plus 5. 1 is common there. Is equals to 0. They're all equals to 0, right? So I'm going to take it one by one. Take these outside terms, x plus 1, and this one of it, x plus 5 is equals to 0. So again, either x plus 1 is equals to 0 or x plus 5 is equals to 0. Okay, so x is minus 1 or minus 5 from that expression. Okay, so inequalities. So for this one, you factor, you see that this is x squared, this is 4x. Factor means you bring out the common factor. So this is the common factor. So either this is less than 0 or this one is less than 0. By the time you find it, you see that x is less than 0 or x minus 4 less than 0. I can do this to be x less than 4. Less than 4. So you have 0 less than x and x less than 4 as the answer. So this is what they call joint variation. Joint variation. So if you have y less than, proportional to the product of x and y, x and z, and y is equals to 24, 24, when x is 2 and z is 3. So you can find what k is. If you introduce this, this is the formula brings k into the picture, right? So we can find k when all these parameters are given. You can find k there. K is 4. So if k is 4, we'll put it at this instance where we'll find y when x is 4 and z is 5. So this is actually very easy. That's what was done here. The final answer is 80. Okay, so if y varies directly as x and inversely as z, and y is equals to 6, find x is equals to 3, z is equals to 2, sorry, when z is equals to 3 and when x is equals to 3 and z is equals to 2, find y when x is equals to 5 and z is equals to 4. Okay, so the solution is out here. Y is equals to kx over z, and we can get k first. Haven't gotten k, we can now go to the second instance and find this. Answer is 5. So this is a quadratic function. So this is the function f of x is equals to x squared minus 1. So let us find f of minus 3. So what it means is that when you see x equal minus 3, so I'll type minus 3 all square minus 1. This is 9 minus 1, which is 8. So this is the answer to this question. And said find the value of x for which 1 over x plus minus 2 is undefined. So undefined means that denominator is equal to 0. So x minus 2 should be equal to 0 for this to be undefined. The value of x for this to happen is 2. Finally, determine the relations whether the relation defined by y squared is equal to x is a function. I mentioned earlier that one input gives one output, right? So for this particular case, for a function, each input must have only one output. So if, for instance, I have x equals to 4, y is either a 2 or minus 2. A 2 or minus 2. Why? Because 2 squared will give you 4, minus 2 squared will also give you 4. So 2 outputs is not a function. It's not a function. So y squared is equal to x, not a function. Why? Because I will be having 2 outputs if I have 1 input. All right. So I hope this video has been helpful for you. I'd like to thank you for viewing. See you in the next lesson. Ensure you subscribe to our channels to get more exciting videos for our channel.